Dr. Hazrina Sofian, Iza Abdul Sani, and Dr. Nazian Jumhari. Okay, so we will have also a moderator by Dr. Aisha Abu Bakar. Okay, so let me just briefly start, give you an overview of the overall presentation sequence. So myself, Dr. Raja Jamila, will be talking about TEALS, the technology-enabled active learning space. And then I will pass to Dr. Hazrina, Dr. Asmiza, and Dr. Nazian for the active learning implementation case studies. And then in the last session, I will actually do a little bit of concluding remarks. And then we will have some question and answer session, or maybe we can just name it as a discussion session for everyone to give ideas, comments, and or can also be questions. Okay, so let me just start with my presentation. I will talk about the technology-enabled learning space, TEALS. Okay, so my name is Dr. Raja Jamila Raja Yusof from the Software Engineering Department. Okay, so basically TEALS, my presentation will cover what TEALS is all about, the introduction to TEALS, the aim of TEALS, and then I will show you some diagrams of TEALS, and then what are the technology, hardware, software, and devices that we use in TEALS. And then we have TEALS we show you TEALS is what is the aim of TEALS, to train future software engineers. And then we have some listing of the courses using TEALS. So this will be my presentation content. So what is TEALS? So the term TEALS stands for Technology-Enabled Active Learning Space. So there are many universities or teaching institutions already using this abbreviation to describe technology-supported learning classroom. So other abbreviation include technology-enabled learning environment, technology-enabled active learning environment. So TEALS is also for us, TEALS is also TEALS is set up as a learning space designed under the Alien Erasmus Plus project. For those who for those who are not our partners that are also hearing this webinar, so it's under our Alien Erasmus project for conducting active learning classes in the software engineering department in our Faculty of Computer Science and Information Technology, University Malaya. So we have also other partners, 14. I think another 13 or 14 universities all around the world. Okay, so what is TEALS? TEALS, Technology-Enabled Active Learning Space, TEALS, in our faculty, University of Malaya. The aim is to equip software engineering students for the workplace to solve future problems, to improve the psychomotor, cognitive, and effective skills in teaching and learning of software engineering courses. So hardware and software are used in the active learning process. So this is the schematic diagram of TEALS. So this is just a schematic diagram. So here you can see that I put actually eight island, but sometimes we make it into 7, sometimes 8, but we can actually make it to more island. But with the workstation, we only have 7 workstation per island. So at most we can have 7 island with workstation. So here, in each of this space, students can interact with each other, and students and lecturers can actually go around the room and see the discussion within the island, and also the students can project their screen from each of their places here to the projector screen in front. So they don't have to go in front to actually do their presentation. They can just stay in their particular island. So this is the picture of TEALS. So this is TEALS without anyone in it, and then these are some of the pictures that we have while students actually doing their discussion or project or some active learning session. Okay, so the technology, hardware, software, and devices used in TEALS, like I told you, just now, there are 7 to 8 islands, and then the 7 to 8 students per island. So the capacity is 49 to 56 students, with movable chairs and tables. So each island is equipped with collaborative workstation, writable surface, drones, Raspberry Pi or Arduino, autonomous car, 3D printer, not each island probably, this is quite a mistake here. So we only have one 3D printer, but of course the students can use it. But they have to take turn on using it. And then we have the movable tables and chairs. And then the software that we have here, they're particularly related to the 3D printing, the projector connection, the PyCharm, Python IDE, the Arduino, and we also have the device tablet. Okay, so these are some of the. This is the picture of um, the our drones. This is the drone. This is the autonomous car. This is our writable surface. But now we actually put them up on the wall. Some are still down on the table, and then we have some sensors and so on. We also have a compartment to keep them in, and then we have Arduino, Raspberry Pi, and the 3D printer. So TEALS, what is the concept of TEALS? TEALS is to train future software engineers. So we try to combine, to enhance the cognitive, psychomotor, and affective skills. The cognitive side and the psychomotor in using the Raspberry Pi, Arduino sensors, or any of these devices, to actually enhance their communication, problem solving, and then also their teamwork and leadership skills, so that they can be trained into skillful software engineers, software architects, deployment engineers, software engineer designers, and software testers. But currently, TEALS is also being used by other department members from our faculty, but particularly we are only reporting those people who are under the software engineering department, because although they are using TEALS, but they don't actually do any reporting and so on, but they actually use the space, the learning space. So these are the list of courses using TEALS in SE department that we are actually monitoring. So we have Agile Software Development subject, and then we have real-time embedded system, software modeling, mobility program, system modeling, community engagement, algorithm design analysis, human-computer interaction, software testing, advanced algorithms, information technology project management. And as you can see here, we use various type of active learning methods, such as project-based, jigsaw, simulation, service-oriented, flipped classroom, bus group, service-oriented. And then we also have this nature-inspired learning. So with that, I will ask the next speaker, Dr. Hazrina, to continue on her active learning implementation case study using, I think she's using simulation. Okay. So Dr. Hazrina. Okay, you can start, Dr. Hazrina.
Assalamualaikum and greetings to all. My name is Dr. Hazrina. Are you able to see my screen now?
Yes.
All right, thank you.
Yeah.
Right, I will be presenting about the implementation of the active learning using simulation for one of our courses in our faculty, which is WQC 7003 System Modeling. To begin with, one of the essence of software system is humankind. Okay, so this is software development life cycle. So it consists of processes from defining the requirement of the um, software to be developed until the completed software that is ready for human to use. So here, once the requirement are defined, means we already know what type of software we are developing. Then it will enter to the second process, which is to design and analysis. Means we actually not develop it yet, but we actually come up with the abstraction. Means the model, the diagram to represent the system to be developed. So this is where we implemented the active learning using simulation. So these are the diagrams, and we implemented the active learning at one of the diagram, which is called activity diagram. So activity diagrams are activity of software system. For example, now we have the navigation software. So the activity will be the user to input the location that we are going, and then the system will calculate the shortest path to reach the destination, and the next activity can be to navigate to users so that they can arrive to their destination. So for simulation of activity that using drone, the simulation guides learner with immediate feedback by self-evaluating the source code or activity diagram with the behavior of the drone. The concept is, as an instructor, we do not need to teach directly, we do not need to teach learner directly about activity diagram. Instead, we imitate or replicate the activity diagram via the behavior of the drone. Thus, the learner will self-observe the activity of the drone, such as take off, turn clockwise, flip 360 degrees, land when it reached its destination. So the objective of this simulation, we have two of them, which is for learner to understand the relation between the source code and also the activity diagram via observing the the drone behavior. Okay, so as a because for the activity diagram will actually serve as the input for the programmer to develop the software system. So um, that is why the person who in charge of developing the activity diagram need to understand the relation between the source code with the activity diagram. And the second objective of the simulation is to give the opportunity for the learners to actively learn about the activity diagram. So the implementation of active learning can be divided to two parts. One is prior to the active learning activity. So we call this preparation phase. It is prepared by the instructor. So there are 5 things that the instructor need to prepare prior to the session, which the first one is the pre-test question. The aim of the pre-test question is to elicit students' prior knowledge, whether they, in this context, whether they understand or they know anything about the activity diagram. And the second one, the instructor need to design the post-test question. This is actually to be given after the session to elicit students' knowledge after the simulation, whether the knowledge they manage to understand about activity diagram after the simulation. The third one, as instructor, we need to provide source code for the drone, okay, so that the learner can execute the able to execute the source code and able to observe how the drone behave. And then we also this is this is actually optional because this is the guideline for students to edit source code of the drone. Okay, sometimes when we have student that is able to understand the activity diagram, we actually allow them to edit the source code um, to comply with the new flight plan that they develop their own. Means they need to come up with the UML activity diagram and then edit our source code. And for the last one, we will need to prepare the UML activity diagram notation. So this is actually the topic that we want them to understand. Instead of giving lectures about this, then we just provide this particular slide. Okay. Now is the execution phase. First, this execution phase was participated by 8 final year students under Masters of Information Technology Management program. And this program is actually give the opportunity for student who does not have a background on computer science. They are one of them is a dentist. One of them is from textile industry, from businesses. Okay, so first when we let them undergo the pre-test. Secondly, the learner execute the source code given and they observe the behavior of the drone. After they observe the behavior of, they will discuss with team member. So when they discuss with the team member, they will discuss within the same workstation. So there were 8 of them, so we split them into 2 workstations. And there were times where they execute the source code several times because they need to observe it a little bit more. Then after they discuss, they draw the UML activity diagram on the writable surface while referring to the given notation of the UML activity diagram. And then once as instructor, at this point, I was just there to give them some guidance if they required. So the step number 6, they design a new flight plan by drawing a new activity diagram. Then they will actually modify the source code while referring to the guideline to edit the source code. So in the end of the active learning session, they undergo the post-test for us to elicit what they have learned throughout this session. So the duration was about 2 to 3 hours. So while they are enjoying learning, this is what we are assessing. Okay, so the pre-test and post-test result, and then the accuracy of the activity diagram, and the third one is the observation. There are 2 things that we can observe here, which is the ability for the learner to relate the given programming code with the behavior of the drone. And secondly, the ability for the learner to modify the UML activity diagram, then modify the programming code so that the drone will comply to the new design. So as a result, although most of them do not have any background in programming, they are able to relate between the source code and the behavior of the drone and the activity diagram. And through the assessment on their activity diagram, they are able to accurately draw the activity diagram, and student feels that they are able to understand the topic via the implementation of active learning using simulation. And we have positive feedback on this because they feel that the active learning is very enjoyable and it's not very burden for them to receive the knowledge. So this is the video that we took in where they observe, and this is when they actually have modified the code, and they actually present the code to the other student in other island. So that's all from me. I would like to invite Dr. Asmiza. Thank you.
All right. Assalamualaikum. Good day, everyone. My name is Asmiza Abdul Sani. So now it's my turn to present what I have done. We have done in the TEALS in regards to applying active learning in our classroom. Okay. So uh, uh, let me first briefly introduce the course that we have implemented the active learning. So in my case, we have implemented active learning into our course called the WIA 2005 Algorithm Design and Analysis, where we choose one of the topic, which is the sorting algorithm. So the objective of this session is so that the student can understand the concept, application, and classification of sorting algorithms. And we have applied these two active learning methods, which is the bus group as well as the flipped classroom. The participants of this active learning session are the second year student of Bachelor of Computer Science program, and we have done it in semester 2, section 2019-20, on to the two tutorial groups, T1 and T2, which total to 80 students. So we have two sessions, two active learning sessions for the students. All right. We have just a week to implement our active learning. So as you can see, we have chose the lecture, sorting algorithm lecture, which is in week 4. Where basically we have done a 2-hour face-to-face lecture. So basically in this lecture, we didn't actually go in depth about the algorithm. All we did was introducing what are the fundamental concepts as well as the basic implementation of each of the sorting algorithm that we covered in that lecture. And then after that, we're going to have another 2 hours tutorial session. And this is where we're going to conduct our active learning, where we are focusing more in depth in terms of the application of the sorting algorithm as well as the classification of it. So during this session, we applied the bus group method, which is done within 1 hour, and that is including the preparation of the presentation. And then after that, we conduct a flipped classroom for the student to present to the class. So why do we use the bus group and flipped classroom for this?
Can you put your presentation mode?
Oh, sorry. I'm so sorry. Okay. So why do we use the bus group and flipped classroom for this session? Okay, so basically we choose the bus group is because bus group is a small, short and intense discussion group method. It's usually 3%. So during that session, for each of the team, even though we have six, but they are given two topics, so it is very appropriate to use the bus group. And this bus group method is also effective for when we have a specific question or we want to find a precise information. Bus group can be used as well to recall previous learning as well as linking concept theories to the implementation. And then we also implement the flipped classroom, whereby we want to allow the student to find their own source of information, as well as be accountable for the knowledge that they shared or they presented to their friends. So during this flipped classroom as well, it enables the student, encourage the student to actually be critical onto the topics that is being discussed, as well as it enables the instructor to assess the level of student understanding in regards to the topic that is being presented. All right. So, for the session, we have do a preparation phase. So basically, this is the where the instructor will prepare the pre and post test question to assess student understanding for before and after the active learning session. And then specifically for this session, we prepare card with the sorting algorithm name. So two each in a box so that the student can randomly pick. So it's something like the student will draw a lot, will randomly pick the topic. We also prepared several set of input data with different distribution. So for different type of sorting algorithm, it is good for so basically it gives a sorting algorithm. You can see that for some sorting algorithm, it is good for certain type of distribution. So we prepared several different set of input data as well as instruction for the students. Session. So basically, in the first hour, the student will do a pre-test where the student will be asked several questions in relating to the sorting algorithm. After that, the student will undergo this bus group activity. Okay, so in this bus group activity, the students are grouped into team of 4 to 6 people, and then each of the team will be given one workstation as well as several writable surfaces to use for discussion as well as presentation. And then after that, from the card that we have prepared, they will randomly draw two algorithms for the team to prepare. And then, so basically, there will be two teams working on one algorithm, but each of the team will have different pairs. So this is so that we will have more feedback when we do presentation. And then they are given 1 hour to have a discussion, find information about the algorithm that they have been given, as well as prepare for the presentation. Okay, so basically, what they have to do is they need to apply the algorithm to any given input element, and then they have to discuss what are the running time complexity for all possible conditions, as well as they need to classify the algorithm into several categories. So we have all these categories. So basically during this session, the student will have to find out which category it belongs to. All right, and then after that, after they have prepared, the student will have to present the algorithm. So this is when we're going to do a flipped classroom, where each of the team will present one. So since there will be two groups that will be looking at the same algorithm, they will be checking each other's information. Okay, so if there's any difference, so they will both of them will show their findings, And then if there's any differences, so they will discuss why, or whether it is it limitation or is it a variation, and so on and so forth. So after that, after we have done the flipped classroom session, the student will also do a post test where they will be asked the same set of questions as the pre-test to assess whether they are able to get the knowledge during the active learning session. And then after that, the student will also answer the reflective question in regards to the algorithm that they have learned. So in terms of the assessment, the effectiveness of the session is evaluated through the pre-test and post-test, as well as the quiz on that topic and the test as well as exam. But the data is still in the process, so the result is not available at the moment. But from the observation, we can see that during the bus group session, we can see that the student fully immerse themselves into finding and documenting the solution using the writable surface, workstation, as well as their own devices. All right, and then during the flipped classroom session, it is evident that we can see that the student are able to identify the classification of the sorting algorithm, as well as critically discuss the application, which includes the implementation of the algorithm, the data distribution characteristics of each of the algorithm, limitation, variation, as well as alternatives of the sorting algorithm. So this is very good with some of the in a sense, some of the information is not being asked, but they still provided it to support any justification of the algorithm that they presented. So these are some of the picture that we have during this session. So as you can see, this is when we have a flipped classroom session. The student uses the writable surface. And this is during the bus group session. The students are discussing using their own devices, writable surface, as well as the workstation. All right, so that's it from me. I'm going to invite Dr. Nazian to continue with our webinar today. Dr. Nazian, thank you, everyone.
We can see your screen, Dr. Nazian. Okay. However, we cannot hear you. Baik. We still cannot hear Dr. Nazian. Okay, now I think we're
Hello?
hearing. Yeah, now I can hear you. Yes.
Okay.
Okay.
All right.
But the screen, yeah, now share the screen.
Okay. Can you see the screen and hear me? Yeah. Okay. Okay, my name is Nazia. I'm going to share about the implementation of active learning in human-computer interaction class in TEALS. So this HCI class, the objective of this course is to the students should be able to understand the student-centered design concept and implement the prototype of the interactive system. And the active learning we use actually is service learning, where the student went to the community, which all the adults, and then that is for group project 1, and for the group project 2, they have to create the game design using the project-based learning. So the participants for this course is majority are second year students in Bachelor of Computer Science, Software Engineering, semester 2 in the session 2018 and 19. And there are 6 tutorial groups that total up to 160 students. This is the largest intake from our departments at this moment, 160 students. Okay, our sessions, okay, based on our previous presenters, they apply the active learning in one subject, one topic. But and Terjamilah, this course actually and Terjamilah and I conducted this course at the early stage of the sessions. So previous structure we had, okay, the total of the study week is actually 14 weeks. So the first 3 weeks we use a traditional lecture, and we still learning on the active learning. But on the 4th week we try the active learning on the group project 1, where the student have to go to the community work, they call it service learning. Yeah, so there are 1, 2, 3, 4 weeks to set up the group project 1, and after the break, another 5 weeks they have to submitted the group project 2, which is the Arduino and Raspberry Pi project. Okay, I'm going to discuss about the implementation, how I run this group project 1. So at the week 4, we started with the card sorting activity and visual information design. We apply this active learning in one topic, and the students are very enjoy with this activity. And then the next week, we start on the briefing of the group project 1, where the student have to go to the community. So as an instructor, I contact all folks home, booking the bus, and then prepare the group project contract. And student will fill up the group project contract, create the interview questions, and they have a role play activity before they meet the real user. So this is the activity for the role play activity after they have created the identifications. And each of the member, they have their own role. For example, for each group, they have 7 members. So 2 maybe will design the identification. 2 person will interview the older adults. Another 2 person maybe they as a photographer. Another 2 person can be a note taker. So this is a picture where they went to the old folks home. And not just they interview the old folks home, they also interview the administrator of the old folks home to understand the whole situations of the user. This is the group. They are also a bedridden old folks home, and students see the facilities available for them. Right. And then after that, they come back, they have to do the critical reflections. Each student have to do the reflections, and I have selected a few reflections from the students where they feel that the old folks home needs some entertainment, such as video game or watching movie. And then during the visitations, we feel empathy and we want to do our best to help the community. We learn that it's important to have interaction with human. This is how they feel the empathy that after they visit the old folks home. The last example, we think that even though we are busy with our work, we should take care of our parents. With that, the old folks home will be entertained with family-oriented activity. And then they have to present their work and submit their group project 1 after the 4th phase. Okay. For the implementation of group project 2, this is project-based learning, where the student will have a briefing on the project, where they have to design the game using IoT that available in our TEALS, which is Arduino and Raspberry Pi, 3D printer, and also the writable surface. So these are the 5 items that they need to submit: the conceptual and user-centered design, the storyboard, design principle, persona, and the usability testing. These are the topics that we're going to cover in this course. So based on these topics, so as a instructor, we need to prepare the pre-test, post-test, and the group project contract, and also the fill form. So this is example of the pre and post-test activity. So this will reflect all the topics that we cover in the item that we're going to cover the topics, yeah. Okay, on the week 10, so this is the technical part where the student will introduce with the Arduino and the Raspberry Pi. And for the first activity for using this Arduino, I just show them the source code, blinking LED for Arduino and Raspberry Pi. And then they try to run the code and explore themselves. So this is an example. This is the code that I give to the students, and also the schematic diagram for the blinking LED. Even though the instructions only using one LED, but after they have managed to understand the flow of the system, the coding, so they managed to light up another LED and another board, and they explore the activity. You know, this is our TEALS environment. They are really focusing on what they are doing. They're very interested with the Arduino and Raspberry Pi set. Okay, you also uses writable space, and even though there are 7 members, so each member they have maybe 2 programmers, 2 usability tester, 2 person learn about the 3D printer. So they are work together like a filmmaker. They have a director, they have actor. So they work, they have their own role in the project. Yeah. So this is an example of the 3D printer. So, and then I will monitor week 11 and week 12. I will monitor their progress using a filler form. Okay, this is an example of filler form where the filler form consists of fact, ideas, learning issue, action, and deadline. This will update every week, and they should update me when I go to their island. So what we know about the task, what do we need to find out, what is going on, and the deadline. So each of the person will update their progress. And lastly, they have to present their work at the week 13. The assessment for group project 1 and project 2 equal 25% and 25%. So these are the items that need to submit for the assessment. And why service learning? Okay, the service learning, actually the student will go to the community and find out the real problem with the real user. So they found majority of the old folks home, they are lonely, they need some entertainment, yeah. So they come back to the university and they develop a game design that can help all the adults in solving their problems, which are the loneliness. Okay, based on the observation, the participants are able to apply the user-centered design concept into practical and collaborate in developing the prototype of interactive system. Okay, most of the assignment, you can go to the alien.fsktmum.my website. There are 23 projects that have been submitted by the students. You can see the source code and everything. I have uploaded in the alien. Yeah. Okay, that's all from me, and I pass to Dr. Raji Jamila.
Thank you, Dr. Nazian. Okay, I will go back to my screen. Hold on. Okay, can you see my screen now?
Yes.
Yeah. Okay, so with that, we had our presentation on TEALS and the implementation of the active learning methods in some of our courses. And um, simulation was done by Dr. Hazrina Sofian. The bus group and flip classroom was done by Dr. Asmiza Abdul Sani, and the service learning and project-based learning by Dr. And as a conclusion, TEALS, the technology-enabled active learning space in our faculty of Computer Science and Information Technology, University of Malaya, have been used to teach software engineering subjects. And the active learning methods used are simulation, bus group, flipped classrooms, service-oriented learning, project-based learning, and also actually nature-inspired learning. I will talk a little bit on that. And students are seen to be actively learning, participating and enjoying the learning session. So with that, thank you. And maybe you have uh, some questions, and I will pass this to Dr. Aisha to moderate the session. And this is just as an advertisement of a future presentation webinar that I will prepare, visualization of algorithm, the spread of COVID-19 coronavirus, the current nature-inspired learning I use. Okay, so maybe Dr. Aisha to continue.
Thank you, Dr. Raja Jamila. I'm looking at our chat box and I have actually invited people to post questions or anything that they would like to ask, but we have not got anything yet in the chat box. So I suppose we would like to welcome anybody to now unmute your mic and feel free to ask our speakers or anything that you would like us to share more, or maybe you have comments and suggestion on how we can improve further on what we have currently done with our active learning and also the TEALS, our learning spaces. I would like to invite anybody. Maybe Harikya would like to say something.
Yes, I have a question.
Yeah.
I have two questions. Active learning is a new methodology that we're using. I wanted to ask you, based on your experience, because I understand that you have used it extensively, do you think it is better suited for some types of courses depending on content, for example, than other types of courses? And also, could you address if there are any challenges based on the size of the class?
Anybody like to pick them up? Honestly, this is my own personal opinion. Maybe some people said that it is suitable. Many people find it very challenging for active learning to be implemented in a very large classroom. However, today I think we have seen an evidence from Nazian, who is having 160 students, and yet she, I would say, proudly presented to us how she managed 160 students, not only with one pedagogical approach. She is actually combining both project-based and also service learning into a course. And she cleverly actually sequenced it such that she actually did the service learning first, followed by the project-based using TEALS. However, I think for those who are new to active learning, they can actually start small, and perhaps they do not need to actually go to the extreme end like the one that Nazian have shared with us today. They can go smaller. They can try something like what Dr. Hazrina have shown us, where we start with just using active learning to deliver a particular activity or subject content, which can be more effectively delivered using active learning activities in classroom. But yes, a lot of people actually have expressed difficulties in applying active learning for a large number of students in a class, and some people do argue that it is difficult to apply active learning in a particular course. But I am amazed with my colleagues because they are new to active learning, honestly. And yet, after we have discussed about what active learning is all about, and we talk about a little bit of methodology and what they can do and how they can modify some of the activity in their classroom, you can see today that they were able to actually did it extensively.
I
Dai.
have one more question. Do you think it is better to have a large number of small teams or a smaller number of large teams? And if you have when the projects are implemented in groups, how do you make sure that all the students are engaged?
Um, we have actually several strategies, and I think you can actually see from presentation of all our speakers that we first of all we install a control process such that we make sure that teamwork is actually developed through them signing either uh, we call it team contract or group contract. We also install things like filler form, and we do check their progress all the time. So I think there are a few um, strategies that we use to make sure that the teamwork is actually developing well throughout the activities or throughout the project. And I think if you look at examples from Nazi, and I'm not trying to pick only one particular active learning example here, but because the one that Nazian has shared with us is the full blown one, so you can see that she also makes sure that each student in a team is actually committed to the role that they're supposed to be accountable to. Whereas I think for Asmiza and also Hazrina, because their active learning activities is not long enough for them to help students to develop full teamwork for over a longer period of time. Uh, However, I think Azrina and Asmiza has done it well by getting their students to really work in teams, and we can see how the teamwork developed over the activity times from the videos and also from the pictures that they have shared with us. So there are several strategies that we have discussed and we have talked about before we start implementing active learning in each of these courses. And we have actually, during our staff training program, we had several consultation sessions where we actually discuss how we can actually design the activity, the active learning activity in the course so that it can be implemented quite structured and quite well. So I suppose that those measures help us quite a lot in terms of making sure that what we would like to implement, although for some of us it is first time and not that we are familiar with. It became quite successful.
I think I can add a little bit more. Why Dr. Nazian class in API was quite a success because although there are many people, 160 students, our management was really concerned of having smaller tutorial classes. So they divided the classes into 7 to 8 session. So I became one of the tutors in 1 or 2 session for this tutorial class. So that's my role in helping Dr. Nazian. So I guess if there are a lot of people in one class, there should be some other lecturers helping out in conducting the session as well. So I think dividing the classes, the tutorial classes into smaller groups session, that is really helpful. And then during each session, we go around one table to another table and see their progress, and we do give comments and so on during that session. Yeah.
May I just also add on Hazrina's experience? Although she only had like 8 students, um, but they are all different backgrounds, and I'm quite surprised how she able to make them work collaboratively with those different backgrounds, and at the end of the day achieve the struggle that Hazrina had concern at the beginning, um, with relation to the course. Actually, during our discussion with Prof. Siti, we actually also discussed each lecturer's concern about their subject. We said that what is it that you are having concern about your subject that you would like to improve, so that you can actually try out active learning to improve your concern. And I think at that point of time, Dr. Hazrina has mentioned that, oh, I would like to try and deliver this, which I think this is quite difficult for my students to understand because they are all have different backgrounds. So we said that, okay, that would be nice if you actually now, try it out and try to do it in an active learning mode using our lab, and actually using all the equipments in TEALS that has been using Erasmus grant. And true enough that today we can see how, as she reported just now, it has been quite an achievement, and it has been successful that students do understand at the end of the day the concept that she's trying to deliver now is that it can be delivered more effectively. Do we have any other question from others, or maybe suggestion on how we can move forward? Dr. Asmiza, do you have anything to share further?
Um, so basically, on my side, as I'm one of the new trying active new in implementing active learning in my class. From my experience, it looks like the feedback from the student are very positive. They really enjoy the active learning class, the active learning session. And since for the session I have conducted, I'm taking care of 3 tutorial sessions, so I only implement the active learning session on 2 of my groups, and I have 1 control group. So it looks like the feedback says that the third tutorial group, they said they wish they can actually join the active learning session, because it looks like their friends in the other 2 tutorial groups are able to actually gain more information about the topics, and are able to see other than just being provided in the lecture slides as well as the text, as well as in the textbooks. So, so hopefully, so I'm planning to actually apply active learning in all of my tutorial classes in the future as well. So yeah, so basically that is some of the things that from my experience that I can say.
I pass the session back to Dr. Raja.
I don't have anything to say, but of course, like Hari Claire's question just now, sometimes some of the things, in my personal opinion, um, you it's quite. I think it's my personal opinion. Some things you need to tell the student in a lecture-based session. Some things, for example, some facts, very dry facts. You can do maybe very short session of teaching them or conveying them some message or some knowledge. Yeah, because I think with you with we should also respect the fact that the traditional teaching has some advantages, yeah, but maybe we should not be doing it for a long period, yeah. So we can add up sessions whereby you have some sessions whereby you actually do teach the student and give knowledge, but and also some part you actually let the student do that some activities, because I do get some feedback from students that I've in my experience in conducting agile system development class, I did it fully active learning, yeah, fully active learning. Um, my role as a lecturer was very minimal. I did not really convey the message. I did jigsaw group. I give them some sections that they need to read, and then they have to go around and discuss the topics and so on. But it looks as if that they don't really like the fact that I don't intervene at all in the conveying of the message. So it is quite a good idea if in the future to improve the session, the course, I would probably it would be a good idea if I in each probably in each week I would give some amount of time, probably 15 to 30 minutes, for me to actually convey some knowledge to them before they actually do the active learning session. So that's my input. Yeah.
Do you have a strategy for setting up the teams?
Setting up. I didn't get your question.
Do you have a strategy for setting up the teams? You know, how, for example, how you put people in a team?
Maybe Dr. Nazian wants to say something about that. She has got, she was doing that most of the time. I was just helping her in the HCI class. Yeah.
How we sorry, how I divided the teams, is it?
Yeah. Yes.
Oh, okay. The best thing, because it's involved programming, so I asked the student, okay, who are the very good programming, please come forward. I mean, because we need to not one group with all the good programmers in one group. So I call up who are the programmer who are very good in programming, because even though they are computer science, so they are sometimes they are not really good in programming. So so we have we give them decide, okay. So all the good students in programming, they will go in front. So and the rest, so I divided the good, maybe one group there are two programmers, and the rest they can join. You can use I use a card, notepad, different with different color, and I give to each student. Let's say 4 color or 5 or 7. So there are 7 islands, 7 different color of the notepad, our note post, and then all the green color they go to one place, something like that. That you can use as a method in terms of the group divisions, team divisions. Yeah, that's all.
Dr. Raja, I think we have one question here. Question plus need some opinion. It says, since most of our class was online and it may happen in future, how we can apply active learning in online mode? I think this is also something that we had discussed while preparing the report. This is actually come up from ASME. And we had discussed how can we now do something like what we have presented, but in an online mode. Honestly, there is also several universities now considering giving they call it toolkit to students. They would like to post the send through normal mail a package to students, for example, the Arduino, whatever, some of the things that we have done in the lab, to students, so that students can actually do it in their remote location. At least my university is having that vision, wanting to actually give students this toolkit so that they can actually do it themselves. For those, I think this is where we lecturers need to be a little bit more creative, where students who have the means to actually buy some of these toolkits, and also maybe some of them who have enough financial support to get the drones and everything, they can actually have it, and we can still use some of the techniques that we have shared earlier on with students. And as far as discussion is concerned, I think by now we are all aware that group discussion can still be done online, where students can actually be put into breakout rooms. Be it we actually use Zoom or we use WebEx and use any other platform. It can still be done. However, to be honest, be it online or face-to-face, the preparation on the lecturer side to conduct active learning is quite a lot, actually. So we cannot say that, just because it need to be done online, therefore we need an extra preparation time. Honestly, if we do it face-to-face as well, actually we need to spend extra time to prepare and to plan for the active learning to be implemented smoothly during the session. Maybe others can actually agree or disagree with my input.
I can share you a little bit. Remember the slide that I share you at the last session? Maybe I can share it again. That it is actually something I conducted currently, but I have not much to report except for what I have already have currently. So can you see my screen? Where's my? Yeah. Can you see my screen?
Yes.
Yeah. So I call it nature-inspired learning.
Sorry, Dr. Jamila.
Yes.
Dr. Raja, are you presenting your slides, because your slides not on?
Can you see my screen?
Screen, yes, but not your slide.
Can you see now? No, is it?
No.
Okay, hold on. Never mind. I've do that while explaining what I've done. So, you know, what I'm doing now is that I'm actually teaching the advanced algorithm class, and I give them a project-based learning a project, and that project they have to observe nature. The nature in particularly they have to observe is the germination of molds and seeds, and they have to relate this germination process with the growth of coronavirus, and from that they have to, you know, each week they have to take pictures of the mold and the growth of the plant. So then from there, they need to do a little bit of analysis on the growth and so on to figure out an algorithm, a nature-inspired algorithm for the spread of coronavirus. And currently they are at it's not completed yet, the project. Will be in a few, I think in next week. So I think they are showing progress, and they're actually doing some sort of although they cannot really see each other all the time and use some equipment, they actually do use a visualization platform called Bokeh, and try to visualize the growth of the coronavirus using the nature inspired observation that they did every week. So that's just my um, my my experience currently. But how successful it will be, I will probably have another webinar on that later on. Okay. Is there any more question? Maybe. Dr. Aisha, so do we want to?
Yeah, I think if we do not have any more questions, I think we can call it a day.
Yeah. Unless someone suddenly say something. Okay. I guess we can stop. Yeah. So I guess thank you everyone for attending this webinar.
Thank you.
Yeah. And hope to see you all. Yeah. Saying something, Dr. Aisha?
Do Prasipi like to say something before we end?
Yeah, Harry Claire, you want to say something? As the
No, thank you.
project
No,
leader?
thank you so much for this presentation and for sharing your experiences with everybody. Thank you.
Thank you so much.
Thank you, everyone. See you all soon. Bye-bye.
Bye-bye.
Bye-bye.